Good evening once again to all. Second, one more introduction for Mr. Ramesh of GEM Orion. Mr. Ramesh Kumar is a CEO of GEM Orion. GEM Orion is a company. It is GEM Equipment and Orion of Japan formed a joint venture, and it is now they have a plant at Coimbatore. I had been to that plant. Tremendous improvement is there. Lot of new products are on the line. When they announced the joint venture, they want to start the program like 4 or 5 products in a year. They told that it will not be possible. That Japanese told that it is not possible. It may take 3 to 4 years to launch the product. But Mr. Ramesh ensured that all those products was launched in 9 months. So big round of applause to all the person. Why I am saying this, it is possible, all of us, all Indians are capable of doing everything. But most of the times, like our friend Mr. Ayappan told, or Mr. Natarajan told, or anybody, even Bhavani, everyone is talking about the capability of us is much. Make use of that. That is very important. So now I request Mr. Ramesh to come and talk about cooling solutions, what they are providing. Thank you.
Good evening. Test cricket match la last session is very critical. So that it decides match draw poda illa yara or team win panna porangala lose panna porangala. I thought நம்ம லஞ்ச் இது டீ பிரேக் இல்லாமல் கண்டினியூ பண்ணுறோம், மேட்சோட ரிசல்ட்டை சீக்கிரம் பார்க்குறதுக்காக கண்டினியூ பண்ணுறோம்னு நினச்சேன். யாருமே இல்லை. தென் வி டிசைடட் ஓகே வி கேன் ஸ்டாப் ஃபார் அ ஷார்ட் டீ பிரேக். ஓகே, ஐ எம் ஜஸ்ட் ஸ்டார்டிங் த ப்ரெசன்டேஷன். ஐ எம் ரமேஷ் குமார். Okay, so I am going to cover about our company history briefly, product range, cooling systems in general, then chiller and its benefits, case studies, and some customer feedback. Probably ipo kuda audio potrundom. Okay, Orion was started in 1946. They started making gears. Then slowly they started making vacuum pumps, milk chilling units, then complete cooling system, air drying system, and temperature control system. Orion is one of the biggest chiller manufacturer in Japan and air dryer manufacturer. So Orion is having 8 overseas factories. GEM Orion is one among them. And our other Indian parent company, GEM Equipments, now it's a 40-year-old company, started in 1984. 3 engineers, just after their graduation, started the company without knowing what to do. Then in 87, they started making dryer. They were the first South Indian manufacturer to make compressed air dryer. And now it's a 40-year-old company. Our association with Orion, between GEM and Orion, started in 2007. When Orion selected GEM as their partner for after sales in India. Orion used to supply a lot of chillers to machine tool industry, especially to Amada, Mazak, Mitsubishi. So for those machines, GEM was selected as a partner for providing after sales service. 2008, we sent our engineers to Japan for training, and then the chairman of Orion wanted the collaboration to extend further. So they gave some design for making air dryers. Then subsequently 2016, a JV is formed. 2017, we started making chillers in India. As Sir said, Orion wanted to go slow as per the Japanese standards, but we were very aggressive. Inverter chiller was not in our product portfolio, but we dragged it. We launched that in 2019. Actually, in 2019, in the same IPI seminar, we first launched our product. We displayed a chiller here. We didn't sell that product in that year. 2020, our first chiller was sold to IPI Plastoteck, Gummidi for making plastic caps. There our journey with inverter chiller started. So this is about the product range. Like Orion, in 1950s, they dreamt of having their own machinery other than gear. So they made some vacuum system. Subsequently, now they are into 5 core technological products like chilling, clean air, vacuum, heating solutions, and temperature control. This temperature control is mainly for precise temperature control or precise air conditioner for 3D measuring instruments or clean rooms or for PCB factories. So GEM is strong into compressed air from 87 to till date. So GEM is having all the products down the line in compressed air, except the compressor. They make coolers, filters, moisture separator, receiver, dryer. Similarly, they have one more product line where they make cooling towers, all types of cooling towers, including dry, the closed loop cooling and adiabatic system. In fact, we supplied few FinFan coolers, the closed loop coolers for power plants. So this is a product range of GEM Orion. We only make chillers. So we have 2 chillers. One is general application chiller where we make economy model as well as the premium model. The economy model is targeting the customers who look for low cost products. And the premium model, our passionate product, inverter chiller and non-inverter chiller. And we have some specialized chillers like dual channel chiller for laser cutting application, wire EDM chiller, chiller for water soluble coolant and hydraulic oil. Okay, in general, if we take our molding application, we need cooling for mold cooling, oil or machine cooling, feed throat cooling and MTC cooling. So in molding, if you see the cycle time, cooling plays a major role. Like if you shorten the cooling time, then you can bring down the cycle time. So the focus is more on reducing the cooling time. So for that, we need to select a right cooling methodology. Before going to how to select, let's see what are the types available. Like we have some open loop cooling, closed loop cooling. Open loop cooling is a conventional cooling tower where water evaporates and thereby the heat is removed in the form of latent heat. And in closed loop cooling, we have evaporative coil cooling tower where the process water is in closed loop and that water is cooled by some local circulation water. And then adiabatic dry cooler, then combination of coolers. And when you go to zero loss category, we have dry coolers, a simple radiator, a chiller and a combination. So to decide on what type of cooling we should select, we should understand wet bulb temperature. So probably you should be knowing what is wet bulb temperature. What is wet bulb temperature? Can anyone say? It is a temperature at which the humidity is 100%. Our RH is 100%. Like if you take Chennai, it's a coastal region. Generally, the RH will be higher. If you go to the central part of India or even interior parts of Tamil Nadu, the RH will be lesser. If RH is less, means then the air is having more potential to evaporate water, moisture, wherever it sees. Okay. In Chennai, you could feel that you will feel sultry. The sweat will not evaporate. It will remain in your body. When you go to the interior parts, the dry areas, even the moisture below your skin is also getting evaporated. So people used to have some sunscreen to protect from that dry climate. Okay. So here you can see one blue-green graph. In an air-conditioned atmosphere, the comfort level is about 60% RH. But the same 60% is a threat when the temperature goes beyond 40. So that is why in Chennai we feel very much uncomfortable, especially during the summer, because here the summer is hot and humid. Okay. So the measurement is very easy, like with the help of a small thermometer and some cotton wig on it, a wet cotton wig, we can measure the wet bulb temperature. So after measuring the wet bulb temperature, now we will decide on the cooling system based on the wet bulb. If you want to cool the media, say it's a water or a mixture of water and glycol, to a temperature above wet bulb, then you can go with a simple cooling tower. That is the most economical way of cooling. If you want to cool the water or the media to the level of wet bulb or below wet bulb, you have no other choice. You have to go with some refrigeration based technique or some chiller. Okay. Now, when a customer wanted to select a cooling system, something he will be having in his mind. Okay, I have written the last thing as low initial investment. Probably that is his first requirement, low initial investment. Then water conservation. We can proudly say that in the entire country, this southern part of the country is more concerned about water conservation because we had already came across the water shortage. Okay, and then the customer is very much concerned about low power consumption. Of course, government helps us to focus more here by periodically increasing the electricity charges. Then higher electricity, higher productivity, the productivity of the components what they make. Then consistent product quality. And the customer should have made a huge investment on the mother machine. So lesser maintenance on the mother machine or lesser downtime for the mother machine. So these are the expectations for the customer. Okay. Now going into the cooling system, like as I said, if we want to achieve a temperature above wet bulb, then this simple cooling tower is more than sufficient, and it is the most economical one. Very simple investment, easy to operate. Just connect with your machine. It will be you'll be getting the cold water. But the problem is the water will be evaporating, and even in Chennai or many places, in South India, people buy treated water, RO water, and they use in cooling tower to avoid this kind of scaling problem. That means already for getting that treated water, some amount of water is wasted. So we are wasting water there, and then subsequently in the form of evaporation, lot of water is getting evaporated, wasted. Okay, so this is a typical data. Like for a 100 TR cooling tower, considering water cost as 5 paise per liter, we are spending about 936 rupees for water in a day. So that means close to 1,000 rupees. In a year, around 3.5 lakhs, which we are not generally noticing. So that is one big threat for using a regular cooling tower. Then when we consider about a closed loop system with little water loss, like evaporative coil or adiabatic system or wet cooling or wet plus dry combo, each one is having its own advantage and disadvantage, but there is some amount of water loss. If we go with a radiator is again a simple heat exchanger which can be used to reduce the water temperature. There are a few applications like diesel generator where you need to maintain the water temperature at 50 plus. So it's very ideal for those kind of application. But here the limitation is you cannot get the water temperature below the ambient temperature. Here not even wet bulb, it will be below the ambient temperature. So looking at all the possible options, chiller looks viable. You can set a temperature anywhere between 10 to 30, and this can be maintained across all the seasons. A cooling tower is depending on the RH. That means during your monsoon, the cooling tower performance will not be the same as it performs in a regular time. Okay. Similarly, here there is no water loss, and the chiller can be used for mold, machine, feed throat, as well as MTC cooling. So chiller, we have many options. The lowest option is with a simple compressor switching on off system like our air conditioner or our fridge. The compressor switches off at the set temperature and again switches on with a differential of 2 to 3 degrees Celsius. So that is having a low running cost and low temperature stability. Okay. But if you see the lowest running cost, that comes from an inverter chiller. So even morning people were talking about energy saving, net zero climate goal. So okay, energy efficiency is the world's first fuel and the main route to net zero. So to achieve net zero, you have to be very much energy efficient. So we say we have a choice with our inverter chiller. So we understand the customer's needs. So, okay, without that initial investment point, I'm coming one by one. Like, customer were expecting zero evaporation. Yes, this is achieved by this system. Customer were expecting low power consumption. Yes, this is achieved by our system because of higher COP or least power consumption. Then productivity enhancement because of the consistent water temperature. Because of consistent water temperature, you are able to get consistent water quality, product quality, and zero time downtime for the mother machine. No scale formation, no dirt and tree. So when you compare a cooling tower plus piping plus pump all put together, it may be similar to your capital cost of a chiller. So the chiller what we have is having a range from 8.7 to 90 kilowatt, and this can maintain the temperature as low as plus minus 0.1 degree Celsius from the set point with low power consumption, and it can work up to 50 degree ambient temperature. So of course, if you just invest on a chiller within 2 years, just by the energy efficiency, the money can be paid back. This is our factory. So we have complete test setup, like we can test up to 140 kilowatt of capacity of chiller, which is about 40 TR. So we have some variants in this chiller. So we say like a low product cycle time or a high power saving or wide operating range up to 50 degree ambient and 30 degree water temperature is achieved with the help of this inverter chiller. And these chillers can be connected in parallel up to 12 numbers, and you can operate because it can communicate among the chillers through RS485 connectivity. So this model is specifically with high flow and high pressure pump for preform, capstan closure and thin wall applications. So additional benefits to the customers is like the size of stabilizers comes down. So we say here, no starting current spike. Even in the home, if you can observe, when your refrigerator compressor switches on and off, like when it switches on, you can see or you can feel the light flickering. That is because when the compressor is switched on, it consumes more current. The starting current of an induction motor is quite high. It's about 6 to 7 times the running current. Whereas in the inverter chiller, it is quite stable. Like the maximum current it consumes is equal to the running current. So because of this reason, even your generator, you need not go for a bulk load capacity. It is very less noisy as compared to a conventional chiller. These are the additional accessories, like we can have a remote display, like when your chiller is placed outside, if you want to monitor from here through RS485, you can connect. Then we can give some filters. We can maintain the electrical conductivity of water through some ion exchange system, and additionally we can monitor flow and pressure. This is how a typically injection molding system is connected. Like for mold cooling, people will be using chiller, and for machine cooling, people will be using cooling tower. So we suggest like this, like a chiller can be connected for mold as well as machine cooling. Few of the machines, like now when you take Shibara machine or some machines are coming with the solenoid valve, which switches on and off to maintain the oil temperature. When that solenoid is not available, we can go with some thermal operating valve, this thermal valve which we have shown here, and the oil bulb, oil temperature can be used to measure and monitor maintain the flow. When we want to connect multiple chillers, we can connect in this way, like we can have hot cold sump with working standby pump system. So various options like chiller can be directly connected to heat load or with a hot well, cold well. The third one is more important, like we have an additional heat exchanger. Uh, in many of the customer places, especially when there is more mold changes, we found that there is a huge amount of water is getting lost. So that is one reason. The other reason, like though they clean the mold properly, many times there are some sediments coming from the mold. These are getting choked in the brazed plate heat exchanger inside the chiller. And this eventually lead to some heat exchanger damages or heat exchanger leakages. So for those applications, we started recommending an additional heat exchanger which is cleanable. So the water beyond this point can be anything. And in that way, customer is free from worries about the water problem to the chiller. Okay, few case studies, like this is for preform industry, for a 48 cavity preform. Here the machine was 180 ton machine, 250 ton machine for a 48 cavity preform, 19.5 gram short weight with about 19 or 20 second cycle time. There was one chiller, competitor chiller in that with that customer. So that chiller was consuming around 21.4 units per hour. This data is based on 24-hour power steady. The same place we are given our inverter chiller, which is consuming around 15.25 units. Probably you can say the competitor chiller is big and our chiller is less. If the chiller is big, the compressor is going to switch off, so off time is going to be more and the on time is going to be less. In that way, so we are pitching against a regular on-off chiller. So here we are able to get about 6 units, which is about 30% power saving. So 6 units per hour means this is about 4.5 lakhs per annum in saving in energy cost. Okay, this is in a caps and closure industry. One chiller connected for 2 molding machines. The power saving is about 4.5 units. Okay, again this is in a caps and closure industry. So here this is in a thin wall industry. So 3 machines connected to one chiller. The competitor chiller was consuming around 15.6 units per hour. To substantiate this data, we have given this, like this is taken on a daily basis for a period of about 7-8 days. So this is giving power consumption per kg of the conversion. Like the existing chiller was consuming around 0.4 units per kg conversion. And our chiller, the maximum, it is close to 0.3. So if you compare this minimum and maximum, even then we are getting 33% power saving. Okay. This is in injection stretch blow molding machine, ASB machine. This is our chiller versus our chiller, like our on-off chiller versus our inverter chiller. This is also in the same case. So the conclusion is that chiller is what you can get a consistent temperature across the season. So that is the ideal choice for mold cooling or machine cooling or for feed throat cooling or for your MTC cooling. So probably we don't have time. So I have collected some voice feedback from customers. Okay. So we thank all our customers on their belief on us. We had a net saving of 50,11,200 kilowatt hour, that is 50,11,200 units during last financial year. Thank you.